right, so today we're going to start in section 19, basic exponent properties. And so today's goals are to develop basic exponent properties and simplify expressions involving exponents. And so we're going to start by kind of refreshing some prior knowledge. Our topic is going to be on icebergs. So there's a paragraph on knowledge about an iceberg, and then comparing a big iceberg with the smallest iceberg, which is called a growler. And so here it's talking about a growler that's off the shore of Greenland. Its volume above water was approximately 27 cubic meters. So what I would like for you to do is, with the person next to you, kind of scoot your chairs together and look through 1, 2, and 3 and 4 and refresh that knowledge. So we have 2 icebergs floating near the growler. One iceberg's volume is 3/4 times greater than the growler. The second iceberg is 2/8 times greater than the growler. Which iceberg has the larger volume? And explain. And we'll kind of look at that together as a class. All right, so looking at number 1. Oh, there you go. Sorry about that. So looking at number 1, so you guys work in your groups, and so this one was pretty easy. I think most of you just got your calculators out, right? So 3 to the 4th times greater than the growler, and then 2/8. So those numbers are great. Do they mean a whole lot? Those 3/4 and 2/8, do they have a whole lot of value as they are? 3/4 and 2/8. Can you compare them in their current state? Are they easy? What did most of you do? Right, you multiply them out, right? You computed. And so 3 to the 4th ended up being, it's 3 times 3 times 3 times 3, which is what number? 81. And then 2 to the 8th is 2 times itself 8 times, which was 256. And so which iceberg is larger? 2 to the 8th, right? Because 256 is bigger than 81. All right, so questions on that one? All right, then in number 2, what is the meaning of 3 to the 4th and 2/8? Why do you think exponents are used when writing numbers? And so with this one, we have 3 to the 4th, and then Allie has 3 times 3 times 3 times 3, right? And in number 1, Tom had computed that to be 81. And then 2 to the 8th was 2 times 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 2, right? And we had that number 1 Tom had computed was 256. And so the question is, why do you think exponents are used when writing numbers? So Allie and Michaela had, it makes the math less lengthy and complicated. I mean, what's easier to write? 3 to the 4th or writing out 3 times itself 4 times? 3 to the 4th, right? And 2 to the 8th is much shorter than 2 times itself, right? So exponents, like multiplication, is a fast way of adding, right? 2 times 2 is 2 plus 2. And 2 times 4 is 4 plus 4. So if you do, that's not too bad. But what if you have 10 times 4? Well, that's, 10 4 times, or 4 10 times. So multiplication is just a fast way of doing addition. Exponents is a faster way of doing multiplication. It's shorthand for it. So in the math terms box, they have some math terms. So we have the expression 3 to the 4th is a power. The base is 3 and the exponent is 4. The term power is also called your exponent. And those are some vocab words that are on our vocab sheet. So we want to make sure that we are familiar with those. as we continue moving forward. So number 3, Grace and Shannon worked on that one. And so it says, suppose the original growler's volume under the water is 9 times the volume above. How much of its ice is below the surface? We know that above the surface is 27 cubic meters, right? And that represents 1/10 of it, and there's 9 times as much below. So when we're talking about icebergs, what we see above the water is a very small portion of the actual complete size of that iceberg, right? So how much of the ice is below the surface? Well, if we know that there's 27 cubic meters above, there's 9 times that below. So there's a total of 243 meters cubed. They have the nice fraction here to represent it. So questions on that one? Number 4, we want to write the solution to item 3 using powers. Complete the equation below. Write the missing term as a power of 3. So that means that it's telling us that the base is 3 and that we need to put an exponent on that. So 3 squared, that represents our 9. So now we need to look at 27. Can we write that with a base of 3? That should be our first question. All right, so if 3 squared is 9, what's 3 cubed? It happens to be 27, right? If it wasn't, you would just keep on going. So 3 cubed is 27. So now we have 3 times 3 times 3. That's our 3 cubed times 3 squared, which is 3 times 3. So how many 3's are we multiplying together? A total of 5. So 3 to the 5th is the volume below the surface. All right, how do we feel about that? We're feeling yes? Getting there? All right, so look at the equation you completed in item 4. What relationship do you notice between the exponents on the left side of the equation and the exponents on the right side? What did we do? Yes, no. Oh, what's the answer? All right, and so what did you do to them to get them to equal? We had 3 and 2. What did you do to those numbers? You added them. So we have this 3 and these 2, and we have 3 plus 2, and that's where that 5 came from. So excellent. Now, why do you think we were able to just add the exponents together? What had to be the same in order for that to happen? The base had to be the same. If we had 3 to the 3rd and 2 squared, would we be able to just add the exponents together in that case? No. So the bases were the same. All right, so we're going to pause for a moment again, and I want you and your partner to work on completing item 6, and then we'll review that together. All right, so now we're looking at item 6, and so we're going to fill in this table. And so we have 5 cubed times 5 squared. And so what's our thought process with this one? All right, so this is very similar to the iceberg one, right? But here, what's the base in this one? What's the base? And the first one down. What's our base here? 5. So we have 5 to the third is represented by those first few. And then 5 squared is represented by those last two 5s. And so when we combine them together, how many 5s do we have? How many 5s are we multiplying together? 5. So we have 5 to the 5th power. All right, and what about in the next one where we have the x's? We have a total of 11 of them. We have our x to the 4th, represented by those first 4. And x to the 7th power here. And so when we combine them, we have a total of 11 x's being multiplied, or x to the 11th. And then the last one, we have our a to the 6th, which are those first 6. And then a squared are the last 2. So when we look at it as a complete set multiplied together, we have a to the 8th, so we have 8a being multiplied continuously. All right, so that was a review, right? You guys have done all of that before, right? So now let's look at what happens when our exponent is not a number, but a variable. So in number 7, based on the pattern that you observed in the table in item 6, write the missing exponent in the box below to complete the product of powers property for exponents. So here our bases are the same, right? We have a to the m times a to the n. So what do we do with our exponents? And what are we doing with our exponents here? What do we do? So this is like a to the 6 plus 2. Yep. So we're going to have our base of a stays the same because our base never changes, right? It was 5 here, and it stayed 5. X stayed x, a stayed a. But now, here we added all of our exponents together, right? Like 4 plus 7 gave us the 11. 3 plus 2 gave us 5. 2 plus 4 gave us 6. So what are we doing with our m and n? We're adding them together. So m plus n. All right. So now looking at number 8, use the product of powers property to write x to the 3/4 times x to the 5/4 as a single power. All right. So what are we doing with our x's? All right. So we're multiplying, right? And the bases are the same. So what can we do with our exponents? We can add them together, and the product of powers property allows us to do that. All right, so we have 3/4 plus 5/4. Now, remember the trick when we're adding fractions. Our denominators are the same, correct? So we can add them together pretty easy. We're just going to add the top. Add our numerators. What's 3 plus 5? So we have 8 over 4. Does that reduce? So we have x squared. How do we feel about the fraction part? All right, so we're going to look at number 9. The density of an iceberg is measured by dividing its mass by its volume. We want to suppose a growler has a mass of 59,049 kilograms and a volume of 81 cubic meters. Compute the density of the iceberg. So over here we have the formula for density. Density equals mass divided by volume, where D is density, M is mass, and V is volume. All right, so setting up our equation here. We have D. Do we know what the density is? That's what we're trying to find, right? So that's what we're trying to find. So density is mass over volume. Do we have the mass? What is the mass? And that is being divided by volume. Do we have the volume? Yeah, 81. So now can we find the density? 29, and then our units would be kilograms over cubic meters. All right, so, and that works out fine, right? We're all good with that? So we just, all we did was we substituted in values into the formula, and we got our answer. Now number 10 says, that's all great, but let's do it in, let's put everything in basic. So it says using powers of 9. So we have, let's start with 81, so that's probably the easy one. How do we use that when we have a base of 9? 9 squared. For 81. 9 squared, right? So our volume is going to be 9 squared. All right. So now, 59,049. So 9 times itself how many times gives us that? How do we figure that out? Well, I would start with 9 squared is 81. Well, what's 9 cubed? What's 81 times 9? Okay, so we're not there yet, right? Because we need 59,000. What's 9 to the 4th? 9 to the 5th? So you just keep going, keep multiplying by 9 until you get there. All right, and then 9 to the 5th divided by 9 squared is how much? 9 to the 3rd, which was at 729, which we found on the way getting to 59,000. All right, so what I'd like for you to do is to talk with your neighbor for a few seconds. What pattern do you notice in the equation you completed in number 10? Between, and since we're talking about exponents, our bases are the same, so what happened with our exponents to get there? All right, so I think most of the groups came to the conclusion that we subtracted, right? That we could take 9. And then what number came first, 9 or 2? When we do our subtraction, which one comes first? To get 3, did we take 2 minus 5 or 5 minus 2? So we took our numerator power minus our denominator power. Because order matters in subtraction, right? All right. Questions? Comments? Frustrations? Grievances? All right. So use the table to help verify the patterns you noticed in number 11. So let's complete this and then do 12 and 13. And then we'll look at 14 together. Alrighty, so filling in the table, we have 5 to the 8th divided by 5 to the 6th. And so we can just cancel out everything because a number divided by itself is 1, right? And so that kind of negates the stuff, that kind of goes away. Because when we multiply by 1, are we changing our outcome? So we're crossing out everything that cancels where we're multiplying, dividing by the same number. And so here we're left with 5 squared. Here we have a to the third over a. So we can cross out 1 on top, 1 at the bottom, and we're left with a squared. And then we have x to the 7th over x to the third, canceling out the 3 that are on top and bottom, and we're left with 4. So that's nice about, dividing. So we can see we're subtracting, and we are showing that subtraction going on when we cross out. So based on the pattern in number 12, write the missing exponent in the box. So if we have a to the m divided by a to the n, what are we doing with m and n? We're subtracting, and our numerator exponent is always first, so m minus n, and a cannot equal 0, so our base is always some number. It doesn't have to be positive numbers. Right? And the reason here is because we can't divide by 0. That would be breaking the biggest, making the biggest crime in math, right? Dividing by 0. Well, can you divide by 0? Can I take this desk and divide it into 0? I either have it or I don't. But I can't take it and divide it into 0. So divide it into 1, that would be this. I can karate it in half, right? But I can't divide it into 0 easily. That's not possible. All right, so number 14, use the quotient of powers property to write a to the 11 thirds divided by a to the 2 thirds as a single power. So what are we doing here? Kayla says we're subtracting our exponent. So how would we write that? What's my base? All right, and what's my first exponent? Look at the first. All right, my denominators are the same, so I can just subtract my top numbers with 11 minus 2. All right, questions there? All right. This is kind of getting into more of the Algebra 1. So let's look at our homework. We'll pick up tomorrow.